lathe is back up. Everything's all set with it now. It's bolted down to the table and we're all leveled. And I have my drill press over there. I have my big cabinet over there. I have my buffer and grinder down here. The only thing I don't really have down here yet is my workbench, which is going to go across that wall, and my smaller little bench, and my bandsaw. I wanted to get them in this weekend, but it did nothing but pour, so throwing them in the back of an open pickup truck wasn't really the smartest idea, so I'll have to wait on that. And also I might want to make either a rack on the back of this table or up here on the wall somewhere to hold all my quick change tooling here, and chucks and whatnot and stuff that I'm going to be using all the time, to hang it on, so that way it's within reach, so it's not just hanging out on the table. I still haven't figured out exactly what I want to do with that, but we'll figure something out. So we're going to take a quick little toolbox tour, and actually a cabinet tour of what's in here, and all the different equipment I have for the lathe, and all the different tools I have to use in it. First off, here's the metal stash for the time being here. These pieces here are water hardening drill rod. This is brass here, mostly, actually it's all 360 brass, although some of these smaller pieces here, I know that some of these are brass and some of these are actually brazen rod. Unfortunately, they're all the same color. I think this might be brazen rod, I'm not sure. So if anybody has an easy way to tell actually the brass from brazen rod, besides heating it up and melting it, drop me a line and let me know. I have a piano hinge, because you never know when you need one of those. So the aluminum that I have, most of this is 6061. At least that's what the biggest piece I have. This is what I made the hand wheels for the bandsaw out of. There's a little piece of plate, some round, some angles, some structural pieces there. This is the miscellaneous steel pile. This is all steel. I'm not sure exactly what alloy these are. I do know that this plate is random. I don't know what Home Depot is calling welding plate. This is what I use to make the jaws, bigger jaws for the bandsaw. And I do know that this bar here is 1018. This other stuff, I have no idea what it is. And this looks really gummy and chunky, so I'm not quite sure what those are. These are all right here are definitely stainless steel. Alloy wise, I have no idea what they are. This right here looks like it was a shaft at some point. I mean, you can see the keyway in it there. It has a straightener on this side, and if I can get this to focus on there, you can actually see what looks like used to be a bearing surface. If you can see those two lines there, I know the glare is kind of in the way, but that's definitely stainless steel though. This is all the 12L14 here. The biggest piece I have is that 2-inch piece, which I used for the bushing for the compound and crossfeed dials. This big piece here, this is actually the original lead screw for my lathe from when it was a change gear lathe. Hanging on to that for the time being. And this is just a piece of 1 1/8 type L copper. Now the difference between type L and M, I'll show you actually. I think I have a piece of type L, type M. No. Okay, there are 3 different main types of copper tubing. 4 if you. There is K, L, M, and was DVW or DWV pipe, and that's the range they go in thickness. Type K tubing is really thick. It's used for super high pressure systems, deep burial, things like that. Type L is slightly thinner than that, and type M is even thinner than that, and the DVW pipe or DWV pipe or whatever it is even thinner than that. Now here is the larger piece is type L, the smaller piece is type M. You can see the wall thickness difference. Also, in your type L's, there is type L, normal type L, and there's ACR type L. ACR type L is not manufactured with any oils. It's a completely dry pipe. Also, the ends are sealed with rubber stoppers, and there's usually either the entire pipe is usually either vacuumed or a slight nitrogen charge, dry nitrogen charge in it to keep moisture out, because in refrigeration, moisture is your enemy. So there's a quick little copper lesson for you. Now let's get to looking at some drawers and toolboxes. See what kind of goodies we find in there. So I figured I'd start with the actual lathe accessories itself. We have a Phase 2 AXA quick change tool post. This is the dovetail type, which instead of being the piston, which is a pin coming right out the face to lock your tool post down, this has an actual dovetail that moves up and down to lock the tool post in. These are a little more expensive than the piston type, but they are slightly more accurate, but they seem to be a little bit more durable to me. Also, as far as locking the tool posts themselves down, it puts pressure on the entire side instead of the piston pushing out here and kind of locking in to like a little part of the dovetail. It's just a little more sturdier. These are the tool holders. This came as a set from Enco. I bought it a while back, and I forget what I paid for it, but I know I definitely use one of those 20% off deals that they have. Usually you have like a 20% off deal if you spend X amount, and free shipping, so combine those. We got this. So this is a turning, boring, and facing. You do turning, boring on the side, facing, and boring wise, I don't know if you can see in there, you got like a little V slot. That'll little notch will hold your boring bar in there when you lock it down. This is obviously your part off tool. Unlike an Aloris or anything fancy like that, this is just a straight slot. It is not a T slot, so you can, some people have modified this to take the T-shaped cutoff blades, but I've just kept it as it is. Works perfectly fine. This, which I have honestly never used. Actually, I've used this to square up the tool post against the face of the chuck, but this is a boring tool holder. Obviously, your boring bar fits right into there. You also have inserts to shrink that hole down. That is I believe, is either 1/2 inch or 3/4. Hang on, let me grab. That is a 3/4 inch hole. So then you have your straight regular turning holders. The only difference between this one and the turning, boring, and facing holder is this one does not have the little V groove on the bottom. All these tool holders can accommodate up to 1/2 inch tools, by the way. And this is a knurling and facing tool holder. Reason why it's just facing is because you can only put it on your tool block this way when you have your handle in the correct position. So it can only go on that way to present the tool bit to the work. The other way is your knurling side. Now, unlike the regular knurlers that have the pivoting head, these are straight wheels. There's no give into this, so this is a little bit more temperamental to get perfectly straight on the bar to make a good knurl. Let's see, what else do we have here? This is also an accessory. It doesn't come with your lathe. Some lathes have it when you buy it, some lathes don't, but it's technically an accessory. This is your threading dial. This is what allows you to sync your engagement of your half nuts with the lead screw to cut your threads. Basically, there are 4 numbers on the top and lines. Depending on what type of thread you're cutting, you engage it on certain lines and certain numbers all the time, so that way you're always in sync with your threads when you thread. Like I said, that is an accessory. These lathes didn't come with it. This was extra. So some lathes have them, some lathes don't, when you find them on the used market. When I bought this lathe, did not have this. I bought this separately. Let's see what else we have here. On the top, we have your regular Jacob's chuck. This is an actual Jacob's brand. It's a 1/2 inch chuck with the Morse tape 2 arbor on there. We also have a live center. It's a little on the beat up side on the tip. I mean, I got a few little score marks on there, but it still runs true, and it's good enough for now for what I need it for. We also have a Albrecht 1/2 inch chuck. This is a keyless chuck. Just tighten it by hand, and the actual torque of the tool bit turning around will actually make these tighter, which is why you don't want to use a reduced shank drill bit in with these. Can you? Yes, you can, but you run the risk of over torquing it because you're using such a large drill bit with that smaller shank, and what will happen is this will tighten down super tight, almost to the point where you cannot get it off anymore. I've actually seen and heard of that happening to people. So just be aware of that. Like I said, can you do it? Yes. Is it recommended? Even from Albrecht it says don't do it. So I don't do it because these things are expensive as hell. Although I managed to find this one at a good deal. Okay, what other little accessories do we have here? We have a dropper. This was for actually lubricating centers when they used red lead and white lead. They used to fill this little reservoir up with it, drop it up, take it in, put it in the center hole, and that was your lubrication. 90% of the lathes that you'll find, this is missing. Mine was missing. This is one that I made. This is actually the first thing I made for this lathe, was this. And that radius on here, to do that was hand turned with a graver and a file. Alrighty, what else do we have up here? We have Kaulitz drawbar. There are 2 types of drawbars for this lathe. There is the hand wheel type, which is what this is, which goes through the headstock and holds on to the collet. And there is also the lever type, which is permanently attached to your lathe and swings out of the back. You basically swing it into your spindle, tighten a little nut on the end of it to screw the actual collet into it, and then you have a lever that you push, and that will actually draw the bar out a little bit, which will actually seat the collet in the nose piece, and that's what actually releases and clamps down on your part. Very, very good for production work. They're relatively, I don't want to say they're rare. On smaller lathes like this, they're actually pretty rare. You'll see them a lot on the bigger lathes, you know, your 10Ls, your 14, 16-inch lathes. You'll see them a decent amount of times on that, but for these smaller lathes, they're relatively rare, and when you do find them, they're pretty expensive. Now, to use this, you also need a nose piece, which adapts your Morse 3 taper in your spindle to the 3C collet. Now, if you look inside there, I don't know if can get it in there. You see that little pin? That engages the actual key slot on the collet. And also used with this is a screw-on thread protector, which does 2 things. It protects you from munging up your threads if you accidentally go beyond where you need to or crash, and it's also used to, when you loosen it up, it's actually used to draw off the collet, and that's how you loosen them. What else do we have here? We have a headstock center. Now, if you notice, this is actually the correct headstock center for the self bend, even though the headstock's spindle taper is number 3. It's a shortened number 3. So if you get a regular 3 Morse taper dead center and try to shove it in there, it'll stick out a good maybe 2.25 inches. This is the same thing, it is just shortened, and as you can see, it has a smaller center inside of it. This fits right into the spindle, and the end of your actual spindle threads will end up right here, so this sticks out a lot less. The only reason why that would kind of concern you is if you have a full-length Morse 3 taper in there and you try to put a dog on there. If the dog tail is short, you're not going to be able to engage the plate. But what you can do is you can cheat and keep the 3-jaw chuck in there, put the Morse 3 center in the middle of that, have it stick out, because it will stick beyond most chucks, and engage the dog with one of the jaws. Not actually, it's not correct, but it works. Okay, so that's pretty much all we got up living up here. Let's see, let me move you down a little bit and we'll see what's living in the cabinets. Alright, under here we have pretty much all our lube that we use is right here. Whey oil, spindle oil, some of the gear, grease. We got a couple of mini hacksaws in here for the time being until I find a good place to put them. These are actually the ones that I had got from Keith Fenner with the Toolbox giveaway. We also have, and down here a little bit, we have some dark sulfur-based cutting oil. This is what I use 90% of the time for just plain steel and stuff like that. It's the same stuff you can get at any plumbing supply store. Works pretty good. I also have some Rely On cutting and tapping fluid. This works really well. This can be used on aluminum and pretty much everything. It works really well. I like it better than the other stuff. The only problem is this is a hell of a lot more expensive than the regular thread cutting oil, so I use this sparingly, but it works great. We have an extra mag base down here because I don't have anywhere to put it at the moment. We have a full this is a Craftsman tap and die set. It's carbon tap. It is metric and imperial, and we also have a bag of 3C Kaulitz. These were actually donated to me by somebody who couldn't use them, so got a lot of those. And this is my original set that I had got. Now is a question I want to ask you guys out there. Let me pull this out so you can see it a little better. This set came pretty much as you see it. These Kaulitz here came in the original Bakelite containers, and they are self-bend branded Kaulitz. Now this box does not look homemade, and actually in this box when I got it was a self-bend flyer, which has since disappeared. Now here's my question. You have the 3C Kaulitz here, no problem. It's a 16 set, so we're from 1/8 inch, I'm sorry, we're from, what are we, 1/16 of an inch to 1/2 inch, I believe. Yeah, 1/2 inch. 1/16 of an inch to 1/2 inch by 1/16, okay? Now this here is kind of interesting. This is an adapter to use 3C Kaulitz. Now here is a threaded insert, and what this here is a 3C taper in the nose. So you pop your 3C Kaulitz in there, pop this on the bottom, and tighten it up to draw it in, like so. Now you can see there are holes for bars to tighten everything. Now, like I said, this case here is fitted to this part. I mean, this part fits perfectly in there. Those Kaulitz fit perfectly in here. But the thing is, I don't know if this is, I'm assuming that this is handmade. I mean, this is a honking piece of friggin' brass or bronze or whatever this is here. And I mean, you can see I have a scratch mark there to mark center. I also have a mark around the edge here to mark the center of these holes. So I mean, it's been laid out by somebody. And I see another scratch mark here to mark the center of these holes. So that's why I'm saying it's handmade. There's also a threaded hole here, and you can see there's a couple of ding marks from where somebody was either putting something in and out of there or what. I don't know exactly what that threaded is. Now there is a through hole to it. That's 1/2 inch through hole all the way through here, and which is as large as 3C Kaulitz go. But I mean, this thing is pretty damn big, and this is heavy. This is for a decent sized machine to sling this thing around. Now this taper here, this is actually tapered. I can't identify this taper. This here, see on the large end here, on the larger side, we're at 1 inch 655 thousandths, and then on the smaller end right here we're at 1 inch 550 thousandths. So it differs 100 thousandths in taper over about actually pretty much exactly 3.5 inches. So I don't know exactly what taper or what type of machine taper that is. And also I mean, I don't know why you would use a 3C Kaulitz system, which is relatively small, on a machine that has a taper that's this big, unless this is for some sort of like grinding machine or something like that, where you know, they could switch them back and forth between machines or some sort. I'm not sure. So if anybody knows what this might be for, give me a holler. Also in here, now this piece, this definitely looks homemade. You can see we're split here, and we have a threaded ring, and these are split, drilled and split to shrink. And this has a flat on it. So this was definitely for some sort of machine to hold this down. And this is not, this hole in here is not tapered really, but in other words, obviously it was used as some sort of, you know, some sort of collet or something to hold something. But this piece here looks homemade. So I don't know what this would be for too. I'm assuming it would have been used in conjunction with this at some point, so I just don't know. But if anybody has an idea or a clue, definitely you know, throw something in the comments or send me an email, because I've been trying to figure that out, and I've asked a lot of people, and nobody can seem to come up with an answer for me. Alright, so let's move on to what's in the drawers of the lathe bench. Alrighty, now we're going to take a poke in these drawers. Now these drawers aren't the best in the world. I made them out of used wood, so they're kind of bowed. I do have to rework them a little bit, but I made them just because I needed some storage at the time. So let's take a look at this one here. Alright, we have most of the stuff that you've seen in the videos in here. We have 6-inch 4-jaw. This is a follower rest, which I haven't used in any of the videos. I have the jaws to it right here. I had taken it apart for cleaning, that's why the screws aren't in it. I do have the screws though, they're in the bag. This is the palm grid milling attachment, which you see me make a video of. It's a dog drive plate. Steady rest, which I modified. I made these jaws. The other ones, the cast iron jaws that were on this, were just worn to hell. So I made these. These are made out of metal, but there are roller bearings, cam rollers in the tips of them. And this is my regular, normal, everyday chuck, which is the Buck 6-inch adjust-true chuck. Alright, let's put everything back here. Go over to this one. Alright, this drawer has pretty much more or less extras in it. This is the gear guide on the side of the lathe, which I couldn't get not to rub on the gear, so I just took it off. This is the original compound screw with the original small dials. You saw the video before of me making a whole new assembly for this. This is the original crossfeed screw. I was able to buy just a new screw and I used that to modify it. I did that just in case I screwed it up. I could still put this back in place, but for the time being this is pretty much extra. This is Cushman 4-inch chuck here. It's got about, it's a little worn. You're looking at like maybe 8 to 10 thousandths of run out on it, so that's why I don't use it. I do use it if I'm doing something that really isn't that accurate and I want a lightweight chuck, or if I'm doing something really small and it doesn't particularly matter accuracy wise. It's a decent thing to have. I've kept it, like I said, it could be made more accurate, the jaws could be ground. I just really haven't gotten to it because I have the regular 6-inch one with the 2-piece jaws that I use. This is the old lead screw bracket that obviously this is where the gearbox is now. This is the stack of change gears. And this is the old banjo back here. And this is a Union 6-inch 3-jaw. This thing is all out of whack. This is pretty much useless as a lathe chuck. But it could be used for any number of setups for welding or whatnot. I just, you know, just can't bring myself to get rid of it. So, alrighty. Give me a second here, we'll move on to the top drawers. Yeah, just had to plug the camera in, we're getting low on juice. So let's check out this here. And up here we have, these are a bunch of lathe dogs. We have that cat's head that I made, you've seen the video of that. This is a indicator holder that I made to fit the ways of the lathe. I'll show you that in a second. And this right here is a thread stop, which I haven't used in the video yet, but I probably will, just to show you how it works. I'll pop it on here real quick to show you basically the way it works. This is just a drill bit set. This is a big ass reamer. What size is this? 2/10 under 1 inch, 0.9998. So that's an undersized reamer. Cheapo drill bit set that's got me by so far. These right here are reamers. There's a long like aircraft drill bits. And reamers, this one happens to be an adjustable reamer. I know it's not really good to keep them all in here like this with the cutting edges down and unprotected, but Right now, this is the only way I really have to store them, so that's the way they have been. And over here are some taper shank drill bits. And what we got up here? Up here we have these are punches, transfer punches, another tap and die set. This blue thing is another tap and die set I picked up at a yard sale for like $2. Quality wise, it looks more like one of the import ones, like Harbor Freight style. And these are a couple of mongrel drill bits that have been floating around. And this right here is a set of, see if I can get it over here. This is a set of BA tap and die kit. That's what this is. And this is also the set that I had got from Keith Fenner on the Toolbox giveaway. We get taper taps on one side, bottom end taps on the other, dies, die handle, tap handle. This goes from 0 to 10 BA threads. Now, from what I could tell, BA threads are British Association threads. They're kind of a seldom used thread now. You'll see them probably, from what I've read about them, because I did look them up because I didn't know what they were. You'll find them most commonly now on precision equipment, things like watches, optics, things like that is where you'll find these. The only place that I've found that is used exclusively in the US is 2BA, which is this size right here, is the thread that is used to thread the tip into a throwing dart. So, a little tidbit of information. So, that's what these are. And they live with the rest of my tap sets over here. Okay, so let me pan you up and I'll kind of show you what we're talking about with the threads. I mean, we'll move this charger wire out the way. Okay, bring the carriage down. So this here, as you can see, has a V cut into it, and that V is set to be able to hang right on the ways here. And it does have a clamp on the bottom, and then you can just stick, this is a 3/8 hole in the side that is perfectly spaced to hit this flat on the carriage. So you can put an indicator on here with the 3/8 shaft on it, and you can indicate your carriage, kind of like a travidar. And this threading stop here is meant to go right on the cross slide dovetail. So you can see there is a tapped hole in the cross slide. There's a screw that goes into this hole here, which I don't have at the moment, and that fits on there. And this sets your starting point for your thread. So when you, after you back out, you always go back to the same spot. So you never have to, not that you never have to, but you don't really have to pay attention as much to your original 0 when you're threading, because this will stop you at where you started the threads if you set it right. Again, I'll probably do a video of this in use, and also you zoom in a little bit here. this actually, on this is original paint, and this is the paint that I had mixed, and that matches pretty damn good. Okay, so that's pretty much for the lathe accessories up here. So let's go to toolbox land.